Page 514, and I'm going to just show you a little app that I've got set up here. Not this one. And on this app, I've got a little unit circle drawn right here. And we know that sine is your y coordinate. So as I move this point along the unit circle, I've got a blue line drawn here showing how long that y coordinate is. Notice that your y coordinate starts at 0, and as I drag it, it draws the curve on the right till we get to the top where it's at 1. So at pi over 2 it's 1, then it starts getting smaller. It's at pi at 0, now it's negative values, and then back to the top again. So in the graph of sine, you can see the cast rule as well. 0 to pi over 2 is quadrant 1, positive. Pi over 2 to pi, positive, then negative, then negative. And all that the sine graph is measuring is as the angle increases, what's the value of the y coordinate? And we can draw the graph of sine. Now that we have this graph, there are some properties that we need to know and some things that we can highlight. So some definitions. We call sine graph and cosine graph a periodic function. Here's the definition. Because it just keeps repeating itself over and over again. The same thing with daylight hours. It's not like you're going to wake up one day in summer and it's just sort of random, oh, today there's only 3 hours of sunlight. That would be weird. Also would be very weird if all of a sudden in the middle of summer we had a blizzard and it was -30. So temperatures and daylight hours follow this periodic or cyclic nature. Okay? We call the length that it takes to repeat itself one period. So on the graph here, they took a minimum to a minimum and said, whatever this distance is, which is 2 pi, is one period. If I started at 0, I'm in the middle of my graph going up. How long before I'm at the middle of my graph going up again? Right here, at 2 pi. So it's really easy to see the period that way. If you start at 0 and say at 0, I'm in the middle going up. How long before that happens again? I have to get to 2 pi to do that. That's called the period. So we highlight that. We know the period of our function is 2. Some other things. With another important definition, it's called the amplitude. The amplitude is the distance from your center line to either the maximum or to the minimum. That distance will be the same, and that's called your amplitude. So some properties of our sine graph. The domain is everything. It's always allowed. The zeros, and this we'll do together. It's a little bit tricky. The zeros happen to be here, here, here. Oh, there's more over here. Oh, and they would keep going. Oh my goodness. Can you see that you would have a 0 at 0, you'd have it at pi, you'd have it at 2 pi, you'd have it at 3 pi, and it would keep on going. And you'd also have negative pi and negative 2 pi, and it would keep on going. So we have to come up with a way of describing all of these. And it's very similar to what you did earlier with the idea of something being coterminal. You look for a pattern. Do you see that all of these are something times pi? Even 0 times pi would account for 0. What this k can't be is a decimal, can't be a fraction. It has to be a positive or negative whole number. Positive and negative whole numbers are integers. So we say as long as k is an integer, z is the symbol for integer. Comes from the German word for number, which starts with z. Solid. So those are the zeros. And we can write them in this form. function has a maximum value and a minimum value, 1 and -1, so the
Excuse
range.
the interruption, staff and students. At this time, we are going to start handing out our registration forms. We apologize for the interruption, but we'll try to get this done as quickly as possible. Students will pick up their registration forms and their course selection sheets from the cafeteria and then sent right back to class with them in hand. So we're going to start with our grade 9s. Our current grade 9s going into grade 10. Anybody with a last
Next
name
graph I'm
A
going to
to
get you to
D?
draw.
That's A to D, grade 9s. Last name A to D.
Cosine graph.
Get to the cafeteria right now, pick up your registration sheets and your course selection sheets. Thank you.
So again, using your axes family from your pie plate, you could draw this. I draw those 5 dots first from your axes family, and then just draw a smooth curve through. Your sine graph and your cosine graph are basically the same graph, just a translation of one to the other. And if we take out our little app and look at it, I add the cos graph to here. So now I've got a red line for the cos graph. That's my x coordinate. I turn on my cos graph, draw that red line. 0 up here, then it jumps to negative. So again, you can see the cast rule. Woo! Don't those little things look like woo? Look like they're having fun. So that's our cosine graph, and we're going to do the same properties for our cosine graph as we did for same period. Okay, again, I would probably use, they use minimum to minimum. I definitely, in this case, would use maximum to maximum, because it would start at 0, and it hits the next maximum exactly at 2 pi. However long it takes to repeat itself, minimum to minimum, maximum to maximum is your period. Just like cosine and sine, both of them have a domain of everything. The zeros of cos are a little trickier. Okay? If we start listing them, they would happen at pi over 2, 3 pi over 2, 5 pi over 2, dot, 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 negative pi over 2, negative 3 pi over 2. And this is an example where it's easy to describe it in words in English, but it's a little bit harder to do it mathematically. Do you see a pattern? You see that's like an odd number times pi over 2? And the odd number can be positive or negative. So in words, plus or minus odd pi over 2. Okay, but this isn't mathematical. So I'm going to show you 2 ways that we can do this mathematically. First is the mathematical way to show all odd numbers. So if I start with any number, any whole number, any integer, it could be odd or even. Agreed? This is like any number whatsoever. As soon as I take any number and I double it, do you see that that would guarantee that it's even? Take 3, double it, get 6, even number. Take any odd number, double it, you're going to get an even number. Take any even number and double it, you still get an even number. So if this guarantees that it's even, what could I do to guarantee that it's odd? Either add or subtract 1. Does that make sense? Take an even number, add 1 or subtract 1, and you're guaranteed to get an odd number.
Hi, excuse the interruption. All grade 9s that are going into grade 10 with the last name initial E to I, please go to the cafeteria. That's grade 9 going into grade 10, letters E to I followed by last name to the cafeteria.
Okay, that's not a problem, so they're not able to sign up on the way?
Involve any orders and stuff.
Okay, I have trouble really with the grade
You know what, if they want to show up and someone doesn't show up, then they can take the seat.
Okay, okay, yeah, come to the parent meeting.
Okay. The other way that you could do that is to notice how much of a hop is it between them. It's the same distance every time. And if the whole period is 2 pi, does it make sense that the hop is always pi in between? So you could either write it this way, if this makes sense to you, odd number times pi over 2, or you can say, I'll start with pi over 2, and then if I make hops of pi, as many as I want, either positive or negative, that will also list all the zeros of cosine. So again, it comes down to which makes more sense for you. And if I can, textbook here, yeah, they did the 2k plus 1. They did the odd one. Here in maximum 1, minimum -1, and a range from -1 to 1. Then on page 516, you can add the graph of tangent. And on the tangent graph, you know how in your unit circle you have some things that are undefined? On your tangent graph, those undefined parts are actually vertical asymptotes. So at 0, pi, and 2 pi, that's where your tan graph is 0. Quadrant 1, your tan graph is positive, that's why it's going up in quadrant 1. Negative in quadrant 2, positive quadrant 3, negative quadrant 4. Almost looks like a bunch of x cubed graphs a little bit, doesn't it?
Excuse the interruption at this time. All grade 9s going into grade 10, last name starting with letter J to M. Please go to the cafeteria. That's grade 9s going to grade 10, letters J to M.
And if I pull out and show on the diagram here, I got tan in green. It's a little bit hard to see. Do you remember in grade 9 that a tangent line to a circle is a line that touches it only once? So I've got a tangent line here. The top part's in blue, the bottom part's in green. And it's kind of interesting because geometrically, if you took the sine value and divided by the cos value, the length of the tangent line from the point to the x-axis is exactly that value. And can you see that here at 0, and that green line is getting bigger and bigger and bigger and bigger and bigger, and then it's really going up. But right at 0, it's going to be problematic. because it would be perfectly parallel, and it would never end up hitting that x-axis ever again, which is part of the reason why it's undefined at the top. And then on this side, now it's going to the negative x-axis, so now it's coming from below. Whoops. And over and over again, you get the graphs. And eventually, we're going to, not to the very last unit, but the very last unit, we will also add the graphs of cosecant, cotangent, and secant. And I'll just show them to you very fast. It's really like, no, that didn't work. Here we go. There we go. There they are. There you go. That's our tan graph. Properties of our tangent graph are a little bit different than the properties of sine and cosine. First major difference. It only takes pi to repeat itself. It's a much different period. Periods of sine and cosine are 2 pi. There is no amplitude because there's no maximum and there's no minimum. The domain, everywhere, actually I don't like that they use words here. It's not actually good mathematics. For the domain, x can't equal, well, if tangent is sine theta over cos theta, that was one of our big ideas. And you're never allowed to divide by 0. Wherever cos is 0 is going to be bad. And we just wrote the zeros of cosine to be odd numbers times pi over 2, where k is an integer. Or you could write it like this, pi over 2 plus k pi, where k is an integer. That would be your domain. The zeros of tangent are the exact same zeros as sine. So here at least, they labeled them correctly. And the range is everything.
Excuse the interruption. All grade 9s that are going into grade 10 from the letters N to R, please go to the cafeteria.
So what's going to happen next is we are going to take these as our 3 new parent graphs. And we're going to go and revisit our first unit and do stretches, compressions, reflections, translations, all of that together. So we're going to have questions that have numbers where we have A, B, C, and D. So if this was a sine graph, the A would be a vertical stretch or compression. The B would be a horizontal stretch or compression. C moves it left and right. D moves it up and down. However, there are some beautiful things that happen with sine and cosine which allow us to develop a bit of a shortcut. So, that's what we're going to start with example 1. We're going to start looking at the A value. And we're going to find out that the A value is connected to the amplitude. And somehow you have to remember that the A value is connected to amplitude. However your brain makes that connection, A, amplitude, I don't know, if you have to probably use some very strategic memorization skills, that the A value is connected to the amplitude, because that's going to help us graph this as a shortcut. Okay? So for A, we want to graph y equals 2/3 sine x. The amplitude of your regular sine graph, here's your regular sine graph, It has an amplitude of 1 and -1 as a max and a min. This is your regular sine graph. This is going to multiply all of your y values by 2/3, which will make your maximum now 2/3, your minimum -2/3. And we're going to learn as a shortcut that if you have your period divided into 4 equal sections, this is just our axes family, pi over 2 pi, 3 pi over 2, and 2 pi. Your sine graph starts in the middle going up. And so 2/3 will just go up to 2/3, back to the middle, down to 2/3. And we graphed it really quite quickly, just by knowing that the A value changes your amplitude. Part B.
Excuse the interruption, all grade 9s going into grade 10, from letter S to Z, go to the cafeteria.
For B, we'll have y equals -4 cos x. So you know your cos graph goes from 1 to -1. 2 pi, pi over 2, 3 pi over 2. This is your regular cos graph. So to graph -4 cos graph, that has a vertical stretch, which is going to change your maximum to go up to 4, and your minimum to go down to -4. Still going to put my period of 2 pi and divide it into 4 equal sections. And a cos graph, you're going to hear me say this often, a cos graph starts at a maximum. So it makes sense that a negative cos graph, because that's a vertical flip, would start at a minimum. So if I know my new amplitude, and I have my 4 sections, I'm just going to jump. Minimum, center line, maximum, center line, minimum. And I can very quickly graph my cosine graph. Circle the following questions for practice.